Hello, my name is Paloma, and for my project, I decided to explore how cotton versus polyester behave when being dyed and exposed to the sun. Before jumping into the experiment, I wanted to quickly go through some of the steps involved in dyeing fabrics. The first step is absorption, which happens when the fabric is submerged into the dye solution and the molecules begin to diffuse into the fabric, which happens thanks to intermolecular forces. The second step is diffusion, which happens once the molecules have absorbed into the surface and they slowly begin to penetrate deeper into the fibers through diffusion. The movement usually occurs due to the concentration gradient between the dye solution and the fabric. Chemical bonding also occurs with reactive dyes used for natural fibers like cotton. Bonds are formed between the dye molecules and a fabric. This is due to the reactive dyes containing functional groups that can react with specific chemical groups present in the fabric, forming covalent bonds. This creates a permanent attachment to the dye to the fabric, resulting in excellent color retention. Ionic interactions can sometimes occur in acid dyes used for protein fibers like wool and silk, as well as basic dyes used for acrylic and nylon. Acid dyes contain negatively charged groups that can form electrostatic attractions with positively charged sites on the fabric, while basic dyes contain positively charged groups that can interact negatively charged with sites on the fabric. After the fabric has been dyed, it is often subjected to a fixation process to ensure the dye molecules are securely bonded to the fabric and resistant to washing and fading. This might involve rinsing the fabric to remove excess dye, as well as being followed by a fixing agent to enhance the permanence of the dye. Once the fixation process is complete, the fabric is usually washed to remove any unbound dye molecules as well as other impurities. This helps to improve the color, fastness, and appearance of the fabric. After washing, the fabric may undergo additional finishing processes such as drying, ironing, or pressing to achieve the desired texture and appearance. The fabrics that I will be using for my experiment are cotton and polyester. Cotton is a natural hollow fiber. 90% of the fibers are cellulose. It is hypoallergenic. It is relatively inexpensive. It's a very breathable and high permeability material. It is also soft, crisp, and cool to the touch. Polyester, on the other hand, is made out of fibers by mixing alcohol and carboxylic acids. It is a form of plastic derived from fossil fuels. It is lightweight, economical, and resistant to wear and tear. It can, however, trigger allergies due to its high chemical makeup, and it is hydrophobic. Now, for the dyes being used in this experiment, we have three. The first dye that I use is the RIT all-purpose dye. It's the liquid version in the color royal blue. It is highly versatile, works for both natural and synthetic fibers. It claims to be long-lasting and it can withstand wear and tear. It is highly popular. It is mostly the go-to option for dyeing clothes at home. It comes with a lot of color options, and the price ranges for about $4 to $11 depending on where you go. For the chemical composition of the dye, the company itself has not published exactly what it contains, but it does have sodium chloride and some specific acid as well as dye. For my second dye, I use the tulip fabric dye in the powder version and the royal blue color as well. It claims to be a 2-in-1 fabric dye with also color boost. The dye is activated with hot water and salt. It works on all fabrics, but it is better on natural ones. Some of the components of the dye is sodium bicarbonate, reactive red 2, and reactive blue 4. Price ranges between $1 and $5. For my third dye, I use the RIT synthetic. I used the liquid version in the color sapphire blue because I was not able to find a royal blue in this type of dye. The price ranges from $7 to $12. It is designed to dye synthetic fabrics that do not readily accept traditional ones. It can be used on plastic items as well, and it is made of the same components as dye 1. For my experiment setup and procedure, what I did is I went to the store and bought 3 different white t-shirts. One was made out of 100% cotton. The other one was a blend of 60% cotton, 40% polyester, and the third one was 100% polyester. I cut the t-shirts into square sections with all the same dimensions, as well as added staples to 2 of the fabrics to be able to differentiate between the 3 different types. For my bath waters, I did 3 different bath waters, each containing the different dyes, all with the same amount of dye and the same amount of water. I used tap water in the warmest setting to be able to have the same temperature across all waters. For the dyeing process, I added each of the different fabric compositions into each of the water baths. So every water bath had 6 pieces of fabric in it, 2 of the blend, 2 of the cotton, and 2 of the polyester. The fabrics were kept in the water for 2 hours, stirring constantly during the first 30 minutes, and then stirring every 15 minutes for the rest of the time. Once the 2 hours were up, each of the baths were drained and the fabric pieces were each rinsed for 3 minutes. Now let's go through the results right after being rinsed and blow dried. This is what the fabrics for dye number 1 look like. Starting from the left, we have 100% polyester. In the middle, we have our blend with 60% cotton, 40% polyester. And on the right, we have 100% cotton. These are the results for the second dye. At the top, we have our blend. On the bottom left, we have the 100% polyester, and the bottom right, we have cotton. And again, this is the results for dye number 3. At the top, we have the blend. At the bottom left, we have 100% polyester, and at the bottom right, we have 100% cotton. After that, I left them for about 3 weeks at the sun, only bringing them inside if it was cloudy and it was about to rain, so they wouldn't be exposed to rain. And these are the results. At the very top row, we have our RIT synthetic dye, and then from left to right, we have cotton at 100%, the blend, and polyester. The middle row is our tulip dye. From left to right again, we have cotton, the blend, and polyester. And the bottom row, we have our RIT all-purpose dye. And again, from left to right, we have cotton at 100%, the blend, and polyester. In conclusion, cotton is much easier to dye due to its high absorbency and hydrophilic properties. It will readily take dye and hold it well, which results in vibrant and long-lasting colors. The fibers also have porous structures that allow dye to penetrate deeply into the fiber and bond with the molecules. The bonds in cotton are much stronger since the color intensity barely faded with exposure to the sunlight. Polyester, on the other hand, it's much harder to dye due to its hydrophobic properties. Because of this, it requires special types of dyes that involve high temperatures, which allow the fibers to open up and allow molecules to enter. Thank you.